Yeah, so I think we are live now. Just a minute. Mhm. I'm not sure why it's not. This one is something they have some problem with it. I'm not sure why it's not. It's not. I think it's not working for us. I'm not sure why. Because if you see here, I can see that. But I think there was some problem with the capture screen and it window capture and this one. So you can see it's working, but I don't know will this work or not. So context is like I got this blog. Um, so I was thinking to cover this blog first. Like I also trying to read and understand what they are mean by this whole thing. If you see who is that, he's I mean a co-founder, I guess, CTO of Jirotha. So he's that person who wrote this blog. Uh, so we are trying to cover this blog. Okay, let us read it and see what we understand it from it. So you can see the code is cheap, so me the talk. So TLDR software development as it has been for decade is over. LLM coding tools have changed it fundamentally for better or worse. So you can see Linus in 2000 said talk is cheap, so me code, but now it's code is cheap, so me the talk. Um when a Linus towards the creator of the Linus made the quip in a response to the claim about a complex piece of programming in Linux kernel, I was obvious gangling, flading teenage noob coder learning by copying paste open source Perl and VB snippet over dial-up internet. The quip has since become an adage in the software world. The gist of it back then was that it was easy to talk about all the software stuff one could like to do or could be hypothetically done. But unless one actually put in an effort and prove it, talk wasn't of much value. Writing and proving a good software was high effort, high cost, high scale endeavor. Um, it's very long. We can, I think, we can cover it in some other. Uh, yeah. So we can cover this after in the last. Let us do it. Like I don't want to read this whole thing. Just copying it, or maybe we can. Uh, yeah, because I don't have that. We can go perplexity. We can paste it and say summary. blog. Send me notes in like points are all important. So the blog was meant to argue that LLM has revolutionized software development, making a code cheap and abundant while uh, elevating talk, articulation, architecture, and critical thinking as the new premium skills. Referencing Linus' famous line, "Talk is cheap, so me the code," quip from 2000, the author contrast past high effort coding constraint with today's LLM powered era where anyone can generate polished functional code instantly. Traditional signals of code quality like docs organization are now unreliable. Forced collaboration faces disruption from infinite slop, and human accountability becomes key to value. While experienced developers switch to steering LLMs for rapid prototyping, junior risk skills uh, entropy, atrophy, atrophy without fundamentals. Ultimately, software development, old paradigms are over. Flipping priorities from typing code to evaluating and directing it. Keynotes. Um, mhm, 2000. Fast forward 2025 towards merges AI generated code, phrasing it. Author with a 25 year experience declares traditional software over as LLM generates 10K lines of quality code in a second. Uh, effort shift, slow power functional LLMs code lack intrinsic value without human provinces efforts, infinite uh, generatability creates morgue mortgage library of Babel's hard to values as trust contrast with a human PRs, evoking empathy for efforts. Human code isn't perfect. Okay. Like if human code is like isn't perfect, is they uh how they are sure about the code which is generated by AI is going to be perfect. Frost implementation, Frost thread on a code, scarcity, expenses, cheap code, erodes, sharing, incentives, stack overflow, decline, future value, curation, governance, trust over a code itself, middle path. Good dev uses LLM pragmatically for quality. Five coders create slow potions. Human hate infinity. Mhm. Human cost for junior beginner without fundamental become dependent on LLMs, missing skill building risk, generation expertise gap, reduced mentoring. Mhm. Reading slash evaluating code is a greater than writing syntax. Articulation architecture trumps coding and skills. Methodologies slash role blurs into fast loops. Commodities like LLMs lower barrier, critical thinking wins. Changing org slash community dramatic hyperboles exist, but core tech capabilities are real and disruptive. Okay, I think the whole concern is this: reading and evaluating code is greater than writing skills. Uh, So juniors contributing to open source. So it says junior CS graduates and early career developers should prioritize building foundational skills and critical evaluation abilities to thrives aimed LLM driven changes in software development. Concrete actions like hands on open source contribution and prompt engineering practices stand out as high impact steps. Yeah, that prompt engineering is also going to be very now important skills for any CS grade or any early graduate engineers. Reason how good your prompt is going to define your like your whole up application. So master fundamentals first, like you should study CS concepts, SDLC, uh, a lot of more things. Practice typing and reading code manually. Start with the Python basics before heavy LLM. Yeah, that was the same thing I was doing because I know the reason to reflection. I don't know, even I don't know in a Golang, but I was going through it and I will try to write this code, will try to understand these codes, will try to make changes in it. I was bit free, that's why I'm doing live, and that was a new thing for me to just see how I am reacting. But most of the time I was wasting this day from last 8 to 10 days. uh, a lot of times I wasted, but through live I can be bit consistent around that. Also, maybe tomorrow or maybe on one of Fab, we will be covering Connect RPC, whole Connect RPC. The whole day we will be reading about Connect RPC, or we will be building things using Connect RPC, and we'll see their repos. Maybe more than 8 or 10 hours. I will be trying to now uh, to I mean, we'll try to build some of our projects around Connect RPC because my whole work going to be around Connect RPC. That's why one, Fab 2, Fab 3, and Fab 4 all will be around Connect RPC. Yeah, mostly will be like building API, building production API. Uh, I think we can close this. I don't know why this is not being. I think it was a problem from. Yeah, exactly. Like there was some problem with the system. I'm not sure, but I can't do anything because we already have around 12 GB of data. Even after that, if they are making such things, then I don't know about it. Yeah, we can see again it. Okay. Okay. If you see, read it. The master fundamental first. Contribute to open source. We are doing open source. Um, Companies like Jet hires junior via quality PR, proving human efforts and accountability that LLM can't replicate. Your GitHub shows already strong supply chain work, aim for 1 2 PRs per month to build provinces, join communities like hackathons or Slack channels. Yeah, you can also use this. Um, let's see how things go more around that. We'll be covering these whole thing. Well, I already know how this whole things works, but I will be covering in more depth. Will build with me and AI around that. Like I will be less, but uh, I will also try to build a lot of things around that. To be honest, I don't like if I get these things, I don't like to be a lot of blogs or things like that. I will be like cleaning up my X to more around databases, distributed system, open source only. No one can talk some other things. I don't have a premium, so it is not working for me. Okay, so our aim for this one is to complete reflection, sync, and context. These three things I'm aiming to complete, but it looks like a way. Uh, but let us see how much portion we will be complete in this. But it was a old blog. So the law of reflection. Um, Reflection in computing is ability of a program to examine its own structure, particularly through types. It's a form of metaprogramming. It's also a great source of confusion. In this articles, we attempt to clarify things by explaining how reflection works in Go. Each language his reflections model is a different and many languages don't support it at all. But this articles is about Go, so rest of this articles, the word reflection should be taken to mean reflection in a Go. Okay. Noted. Noted. Note added January 2024. This blog post is written in 2021 and predicates parametric polymorphism generic in Go, although nothing important in article has become incorrect as a result of developing in the language. It's been tweaked in a few places to avoid confusion, sometimes familiar region with a modern Go. So if you see the types and interface, because reflections builds on the type system. Okay, so reflection builds on a type system. Let's just start with a refresher about types in a Go. Refresher. First time I'm hearing refresher. Go is statically typed. We know about it. Every variable has a static type. That is exactly one type knows and fixed at a compile time, like integer, float 32, some other types, byte, and so on. If we declare the type my integer as integer, variable I integer, and variable j my integer. So my integer also is an integer, so j is also integer. Then I has a type integer and j has a type my integer. The variable I and j has a uh, distinct static types, and all through they have the same underlying type. They cannot be assigned to one another without conversion. Okay. One important category of type is interface type, which represent fixed type of methods. When discussing reflection, we can ignore the use of interface definition as constraints within a polymorphism code. An interface variable can store any concrete that's non-interface value as long as that value implements the interface methods. A well-known pair of example is io.reader and io.writer. The type reader and writer from io package. So we have a reader. Readers is an interface that wraps the basic read method. Hmm. So type reader interface read and the looks in interface we structure the type are the methods like what are the types they accept and what the type they return. So reader p as a array of bytes and it returns n which is integer and error. Writer in the writer in the same way the writer. So any types that implements read. Yeah, exactly the same thing I was talking. Any type implements a read or write method with this signature is said to be implement io.reader or io.writer. So for the purpose of the discussion, that means that a variable of type io.reader can hold any value those type has a read method. Okay. It is important to be clear that whatever concrete value R may hold, R as type is always IO not treated. Go is statically typed and static type of R is IO dot reader. An extremely important example of interface type is empty interface. So this is an interface or its equivalent alias any. Mhm. It represents the empty set of method is static is satisfied. I was thinking it was statically. So it represents the empty set of method and is satisfied by any value at all, since every value has a zero or more method. Some people say that Go interface are dynamically typed, but that is a misleading. They are statically typed, and a variable of interface value always have the same static type. And even though at a runtime, the value stored in a interface variable may change type, that value will always satisfy the interface. We need to be precise about all this because reflection and interface are closely related. Okay, the representation of interface. So a variable of an interface type stores a pair, the concrete value assigned to the variable, and the value type descriptor. To be more precise, the value is the underlying concrete data item that implements the interface and the type describe the full type of that item. Yeah, look, one of the thing I have learned till this point is like you can read 10 books or a 15 books, but even after reading 10 or a 15 books you are not sure about it, will you able to write the code or not? It's not in their hand. But like practicing the questions or writing a code or building the application is going to help you with it. But the problem with me is like I tried it to learn things through the reading this, but I also like like I also don't like reading a lot. But I was trying to cover things bit of once I can cover this um, and then try to build things. I think maybe what we can do start building this application and then try to, but we will try to do it tomorrow. We will try to cover tomorrow 2 or 3 things. But there was some of more thing which is very important, like reading files, templating, generic. So that's why I was reading, but yeah, at the last I don't try to, but for the fundamentals, you need to read things more But you know what, like I don't like much, and that also does not help me a lot, to be honest. Okay, so a variable of interface type is store of a pair. The concrete value assigned to the variable and that values type descriptor. To be more precise, the value is underlying concrete data item that implement the interface, and the type describes the full type of that item. For instance, after var our io.reader, then we are reading, like we are opening a file, and then if it throws error, we throw the return. If it's not, then we takes that. R contain schematically the value, comma pair, the value comma type pair tty is as os.file. Notice that the type os.file implements methods other than read, even though the interface value provides access only to read method. The value inside carries all the type information about the value. That's why we can do things like this. Var w io dot writer w equals to r dot io dot writer. The expression in this assignment is a type assertion. What it asserts is that the item inside R also implements io dot writer, and so we can assign it to W. After the assignment, W will contain the pair that is like tty, os dot phi. That's the same pair as what was held in R. The static type of the interface determines what methods may be invoked with a with an interface variable, even though the concrete value inside may have a larger set of method. Continuing, we can do this war empty interface. Okay, we can read this. The first law of reflection. Reflection goes from interface value to reflection object. I mean, where it is used. Reflection means is ability of a program to examine its own structures, particularly through types, and modify its behavior during runtime. It is a form of metaprogramming that allow code to work with a data whose specific type is not known at a compile time, which is critical for building generic library and dynamic tool. Okay. Means it's in the simpler way the ability of the program to examine its own structure uh, through the types, and it can also modify the behavior at runtime. Maybe we created some uh, our own type, but the Golang does not recognize that type because it was not implemented, uh, not into the official one, but it's some generic. So at compile time, they don't know. Yeah, so the specific type is not known at a compile time, which is critical for building generic libraries and okay. Modify its behavior during runtime. Reflection goes from interface value to reflection object. At a basic level, reflection is just a mechanism to examine the type and value pair is stored inside an interface variable. Mhm. To get started, there are two types we need to know about in a package reflect, that is type and value. Those two type give access to the contents of an interface variable, and two simple function called reflect dot type of and reflect dot value of. Mhm. What is reflect dot type of and the other is reflect dot value of? Retrieves reflect dot type and reflect dot value piece out of an interface value. Also, from a reflect dot value, it's easy to get to the corresponding reflect dot type, but let's keep the value and type concepts separate for. Let's just start with the type of. So like package main imported fmt reflect function is var x float 64 equals to 3.4 fmt dot println, that is like a type, and we take reflect dot type of the value, whatever the value they have. This program prints type float 64. You might be wondering where the reflect is. Since the programs looks like it's passing the float 64 variable uh, x, not an interface value. To reflect the type of return the e-reflection type of the value in interface. So it returns in the reflect in the interface, right? Okay, that is good. So the program prints like if it is a 60, if it is a float, then it is a float 64, and you will get a value like float 64 and that value. So here you will print float 64, kind is 64, v dot kind float reflect, and then v dot float is 3.4. Okay. Second law is reflection goes from reflection object to interface value. I don't understand. I don't know what does they mean about here. It's a very simple. There was a two thing. One is a type of and the value of. You can use the type of and value of, and it also returns in a like value of returns in an interface type. That is a simple thing. A reflection goes from reflection object to interface value. Like physical reflection in a go generate its own uh inverse. I think, yeah, like building things could be good, not covering things or exploring things could be not that much good, I think. Okay, like a physical reflection in a go generates its own reverse. Given a reflected value, we can recover an interface who interface value using interface method. In effect, the method packs the type and value information back into interface representation and returns the result. Okay. As a consequences, we can say y equals to v dot interface float. Y will have type float 64. V dot interface to modify reflection object. The value must be uh, settable. Okay, I think we will be covering more in that reflection. Yeah, just a minute. Okay, right. Golang challenges write a function walk with taking x as an interface and function in which takes a struct x and calls function for all string field found inside difficult level recursively. Reflection and compounding is ability of a program to examine its own structure, particularly through types. It's a form of meta programming. It's also a great source of confusion. Great source of confusion. Yeah. So, what is an interface? We have enjoyed the type safety that Go has offered us in a term of function that works with a known type like a string, integer, our own types like bank account. This means that we really sorry. This means that we can get some documentation for free and compiler will complain if you try and pass the wrong type of right and wrong type to function. You may come across a scenario through where you want to write a function where you don't know the type at a compile time. Yeah, yeah. These things happens a lot of time. Like we don't know the type. Go let us get around this with a type interface. Mhm. So interface like you can get any type, which you can think of just as any type. In fact, in Go, any is an alias. Any is alias of interface. So work X interface function takes a function as a string will accept any type for X. So why not use interface everything and have really flexible function? Yeah, so uh, as a user of a function that takes interface, you lose type safety. Yeah, that's the same thing I was trying to say. What if you want to pass her dot species of a type string into function, but instead did her dot count, which is an integer type? The compiler wouldn't be able to inform you the mistake. You also have no idea what you are allowed to pass to function. Knowing that a function takes a user service for instance is very useful. As a writer of such a function, you have to be able to inspect anything that has been passed to you and try and figure out what the type is and what you can do with it. This is done using reflection. This can be quite uh, clumsy and difficult to read and is generally less performant as you have to do checks at runtime. In short, only use reflection if you really need to. If you want polymorphism functions, consider if you could design it around an interface, not interface confusingly, so that user can use your function with a multiple type if they implement whatever method you need for your function to work. A function will need to be able to work with a lots of different things. As always, we will take an iterative approach, writing tests for each new things we want to support and refactoring along the way until we are done. Yeah, that was a really good approach, to be honest. Writing test first. So what we are trying to do here, mm, we expected Chris and were got as an array of a string, and X is an struct which takes name strings and then expected to be Chris. Okay, walk is X, function takes an input of a string, got equals to append, and it will append the input, whatever the input we get. Okay, what is X? X is a struct. I did not understand it. What exactly we will be doing? We want to store a slice of a strings that's got, which stores which strings were passed into function by walk. Often in a previous chapter, we have made dedicated types for this to spy on function slash method invocation. But in this case, we can just pass in an anonymous function for fun that cruises over God. We use an anonymous struct with a name field of type string to go for simplest happy path. Finally, call walk with X and spy, and for now, just check the length of God. We will be more specific with our assertions once we have got something very basic. Okay, okay. I'm copying it. Now we are going for reflection. We want to test walk. So here we want something expected, which is we can say Krish, and we got as an array of a string, right? Maybe we can do it or with a type. And we want X as a like a struct which is an struct which takes name as a string, struct which takes in a string, and then we can expect it. Is it right or something wrong? Not a struct, it's a struct. So it's expected. And then we have a walk as a function which takes X and it takes an input which is a string type. Sorry, not a string type. It takes a function right? It's right. Yeah. And then you take that as got. Got is already defined, so we do append with the got and input. And then if length of got is not equal to 1, mhm, then wrong number of function. So now we want a function which is walk, which takes an interface. I call interface and a function which takes a string. I think I don't have to do in this way. Then there is also an fn. Yeah, like that. Okay, now it's running. I still can't believe South Korea beat Germany 2-0 to put the last in their group. So writing the test, okay. Uh, we can walk through a wall that's a reflect dot value of x, and then fill equals to wall dot fill 0. I think someone trying to post some link, but night board just block that. So, like here, what we will do that reflected value of taking x and the field will be like value on field 0, and then we will pass through the function which will be in a field dot string. um, like this code is unsafe and very naive, but remember our goal, when we are in red, the test failing is to write the smallest amount of code possible. We then write more tests to address our concern. We need to use reflect to have look at x and try and look at its property. So reflect package has a function value of which returns value of the given variable, and this has a way for us to inspect a value including its field, which we can use in the next line. We can make some very optimistic assumptions about the value passed in. We look at the first and only field. However, there may be no fields at all, which could cause a panic. And we then call string, which returns the underlying value as a string. However, this could be strong if fields or has uh, if field was something other than a string. Yeah, if it is other than a string, then could be it issue. There could be issue. But we are also like, if you see what they did, wall x dot again reflect dot value of, it takes the x and then it takes a field which is wall dot field, which is a 0, and then they pass that field as a string. to that. And if we run that, will this pass or not? It got passed. Okay. Now we are changing this. Our code is a passing for a simple cases, but we know our code has a lot of shortcomings. We are going to be writing a number test where we pass in different values and checking the array of strings that that function has called with. We should refactor our test into a table based test to make this easier to continue testing new scenario. So if you take the cases here, we take some cases of name, then input, and then expected calls, which takes an struct with a one string field, and then we have an struct um into interface type, and then we have an array of a string. Okay, and then we are taking that cases and then t dot run, which takes a test dot name. Test dot name and then a function where we got this and we walk through that test dot input. Mm-hmm. And then we'll check that expected thing. Okay, that looks good. Hmm. Okay, we can do something like this. That cases will be into this struct, right? That struct will take the name, which takes the name as a string, just like how we do here. Because this is an array, then this needs to be whole things into, yeah. Now we can do format this. Okay, so these whole things are, now you can do for and then case or test. And t dot run, which takes name, so test dot name you can do, then you can take function, and And in the function, if you see these whole thing, the walk takes test dot input, and a function which takes s dot string got and or into test dot input. So you just need a got. So here you just take it into the or dot string. Not input, I mean it needs to be s, right? The got needs to be the input, and then in that way you can go reflect dot deep equal. You can just delete this whole thing into the walk if it does not equal to reflect dot deep equal takes x is like got, and expected will be test dot expected, and then if it is not, then you can just call this, right? And you can run this, but it will fail. It will pass. Okay, it passed. Now you can run add a scenario. um, let's take, you have taken some more, like you have deleted something like city, which also takes a string, and then in the city you did a London, and then that string will also expand, and then you try to run this, it fails. I think the expectation becomes different, and now you may think of there is like, if there is a more value, then how we will going to manage that, because like you got Chris, but they want something like Chris London. And now you are just checking first field. Now you have to check second fields. In I mean the second value, third value, fourth value, like that. Now you can just change this whole thing into not in that fields. You can change this into for I equals to 0, I less than 12 dot uh, number field, number fields, and I plus plus. And now you can just do the same thing. How you take the fields and take the field of that value, and then you can just pass function not a string, right? And then run that function. It got passed. You can refactor this. I don't think so. There's a much refactor. It does not look like any obvious. Write the test. You can take the test. Now age, which is an integer. Uh, that needs to be like that needs to be a string. So if you're passing this 33, then you can just ignore it. That needs to be a filled type of, like if they did something like age, like take age, which takes integer, and you did something like 77, and then you just try to run that, failed, it got failed. Then what you can do it here, if like filled dot kind is uh, if reflect dot kind, right? Reflect, not reflect dot kind. I mean, field dot kind. Okay, field dot kind is equals to uh, reflect dot string, right? Field dot string. Sorry. Um, that needs to be exact. That is reflect dot. Oh, sorry. That needs to be a call. Yeah. Now, if you run the test again, they will just ignore age. If you added some profile, I mean, into this struct, you just defined one more struct. Now, if we add one more struct inside a struct, means in an inner struct, uh, yeah, and to be honest, it looks messy now. Like if you do something like this one, so it's good to add a type of person struct name string and then a profile. That looks good. Now we can just add like Chris and then profile as 33 and age is London, like that. So if you so the name is in a person. You can just do these things. You can remove this and do a person, and that person have a name as a Chris and then a profile. If you do like this, then it will say like this. Now if you run this, it will fail. Sorry. So got Krish, want Krish London. So what you can do now, this one is good. If it is an struct, you can again walk through. I mean, if it is again as an struct, you can just call it again the field walk, which we did it previously, like that. Mm. Now it got passed. Reason, but it gets like inside. Oh, you go one more depth. I just thought of one more depth. So it's not looks really good, to be honest. It does not looks really good. We can do in the some of a type of select. So select is like a fill dot kind, and that kind is an if let's take reflect dot string, then it will call this, and if it some other, then you can do like you can thought of which field is common, that is a field dot kind, so you can do. Is there anything wrong? Oh, sorry, not select, I mean switch. I was thinking, what is wrong with me? A case which is like a reflector string. In this case, you can just run this. And now you can run it. Once. Okay. So let us take one more step. We pass it as an ampersand. Like it pointer. We are doing a comparison on the same value more than once. Same value more than once. Generally, refactoring it and switch will improve readability and make your code easier to extend. What is the value of a struct passed in is pointer? Acha. I mean, if it is as a pointer. Okay, we are trying to pass this as a pointer. Then if we run this, it throw an error. So it calls a panic reflect call of panic dot value dot num field on a ptr value recovered panic reflect call of. Mhm. How can we improve that then? Think about it before looking at the code. What we can improve, like if it taking as an a person, then this is not going to be possible. Uh, like if it is on a pointer, then we can't access that thing. If it is a kind, then it is some ELM. Okay. So you can't use num field on a pointer value. We need an extra the underlying value before we can do that by using ELB. Okay, so if there we will change the value. Now it go into pass. Like you can get a value. Like this you can change this whole thing. If it is a value dot reflect dot value takes an x as an interface, and then the another one is will return reflect dot value because this one is totally returning reflect dot value. World dot reflect dot value of x, and then try it if it is a wall, or this one is a reflect dot value also, but this elv is for pointer. You can just remove this call x, I mean one variable, we'll call it. This actually adds more code. If we pass it as an array of a string, okay, even array of strings is wow. Now if you call all of reflect.value.numpy on slice. Now we will be writing like this as a variable dot kind equals to reflect dot slice. Then we walk through wall dot index of I and then interface. Nice. Call of reflect dot. Now we need to add in a condition here. If wall dot kind is equals to reflect dot size, then we will do for I to the wall dot length for x. So x is, it will be wall dot index of I dot index or interface. I think it's interface. What it does is, and it takes a value. So it would be wall.field or function. It will be fun. I mean, here is the one. Oh, sorry. Yeah, really. In the last one, we try to do it with the filled data strings. Now we need to do it through wall, which is a wall dot kind, and if it is a reflect dot string, then we will try to run such things, and then if it is a slice, then we will run through a slice. The struct one is the struct one also wanted, so it is around num field. Like in this, it is a wall field, and in this wall index. We are here. We already did that. Now it's time to refactor it. So this works, but it's yucky, I say.
Yucky.
No worries, we have working code. We have working code backed by tests, so we can are free to think, or we think. If you think a little abstractly, we want to call work on either each field in a struct and each things in a slice. Our code at a moment does not reflect it very well. We just have a check at the start to see if slice within a return to stop the rest of a code executing, and if it not, we just assume it's a struct. Uh, we are trying to do something like this: switch wall.kind. uh Look here, we will try to uh, add the cases like uh, reflect.struct, reflect dot struct. Oh, sorry. If you take a reflect.struct, you can take here, which is we are calling work on a field dot interface. But here we are not having a field. Field, how we can get a field dot when we talk on a work dot field. Now what you can do, because that one is a num field, because we have not added any other things but that are into the num field, they comes into the num field. So you can take that num field, wall.num field, and then call these whole thing like this. So this is the similar thing what we are talking about here. Here you can see this one. This. Mhm. And the other case is uh, reflect dot slice. So into the slice, you can just copy this one because this is the whole thing. So you can just copy this whole thing and you will get that. And into the case of a string, there was nothing to change much because here you can just talking about Paul could help you, and you just delete this and you can just delete this one too. Right now, if you run the dash, it will pass. Uh, just a minute. It needs to be London and whatever. No, it passed. Okay, now it passed. We are changing more things now here. Look at this, how we are changing now. We are now changing it with the number of value. So what we are doing, we are taking the get value first. Number of value is 0 and we are taking a get field which takes a function as an integer and then send us a reflect dot value. we are doing the same thing, but here we are calling a number of value is vol dot uh, number field. Okay, after the number field, what we are doing, we are taking a get field. That get field will be vol dot field, or into the slice it will be vol dot index. And then we are just calling it. If it comes at a reflect dot slice, then we can get that one in that one. Yeah. So it looks really simple now. If you keep these things as simple, but just add one more thing. I think we can now everything we can hit add it and reflection. Okay, so we committed reason for changing some of the things, so we can um take a look like what are the change. Number of field, maybe number of field or number of value we can do. Number of value equals to 0, and we can do war get field, which takes a function of integer and return a value of reflect dot value. Hmm. Now we will take this whole thing as here, and we'll do here. Just you can just go look at that. Uh, Here what we need number of value. Number of value here calls from value dot num field, and here the number of value will be from value dot index. I don't know how we will remember this thing. And number of index, sorry, not number of index, I mean wall dot length, number of length. Okay, but if you see the code here, it will be here as a wall dot length. Okay, that's good. And get filled will be from, it is a reflect dot value, then this will be wall dot filled, I think, wall dot filled, and here wall dot index. Get filled equals to wall dot index. There will be nothing. And do they reflect a string? No, in reflect index, I don't think so. They need anything. They just call the function there. Okay. So here we will change this thing to this one to number of value, and here is just to get filled, uh, get filled of I. On that I we will call an interface. Got it? Yeah. But the problem with here is like how we get to know about this is wall.num fields, this is wall.length. You can think about a slice because yeah, we can. And then get field is wall.index and wall.field. A wall is just a reflect dot value. Some of the things are confusing here. If the value is reflect dot strings, then we can just call function like normal. Otherwise, our switch will extract out things depending on the type. How many fields there are, how to attract value, field or index. Once we are determined those things, we can iterate through number of values calling walk with the result of get field. functions. Now we are done. This handling array should be terrible. Write the test first. So now we are changing this to not having the a large value but two. Just by doing this, you can see it will start failing. We got this and want this. uh, although also it doesn't do like it needs to be two. You can't be more than two, three, or four like that. A array can be handled the same way as a slice. Now it is an array, not a slice. So here you can just add one more parameter, I think. Reflect.string struct slice. Then now why it is failing? Uh-huh. Uh, okay, just you have to change the slice to take the reflect.array, and now you will call this and then start passing. The next type is map. The next is map. So in maps, here you can do map if you want to map, and then you can just change this whole thing into a map of string of a string. You just have to change this whole thing to call cow most like ba, and then here will be mo, and here will be ba. And if you run this, they will call it got this but want this. I think now you have to pass the case as a reflect dot map. So you need to call reflect dot map, and then you just have to take the map keys, and then you just take a value from there, from a map key. By taking a key, you will get a value. Yeah. Here you can add this one. I think could be above. Looks really cool, and you can just add a case of reflect dot map, and for takes a key into the range of wall dot map map key, and map key is a bit of type of array of value, and that value is like something like that. Now you can just, I think you have to call walk, and that walk will be uh, it will be a wall uh, dot field or a map field map key, and that will be, sorry, that will be key map index, sorry, not map key, map index, and key, and then interface. Yeah, not passed. However, by design, you cannot get values out of map by index. It's only done by key, so that break our abstraction. How do you feel right now? It felt like maybe nice abstraction at a time, but now the code feels like wonky. Somewhere wonky, somewhere yonky, somewhere donkey. That is okay. Refactoring is a journey, and sometimes we will make a mistake. A major point of test driven development is it gives us a freedom to try things out. By taking small steps backed by tests, this is no way and a irreversible steps. Let's just put it back how it was before the refactor. So this was something like this. Okay. He said just cut this whole thing and get back to what you have before. So before we have something like uh, for I equals to 0, I less than wall dot num filled and I plus plus, then just call walk, and that walk will be wall dot filled of I and a function and a function. This is this, and then for I equals to 0, I less than wall dot length I plus plus, that is walk, and walk is wall dot index, which takes I, and then an interface which takes a function again. If you take a map is also look in the same way. uh, this one can remove that, and this one also. This one looks really, if you see that all threes are in the similar, so you can mm, say a walk value which takes a function, uh, which takes a function value of interface, and you can call a walk a value and a function, right? I mean a value dot reflected value, sorry, not interface. We can say a reflect dot value, and this value dot can call interface on that. Okay, and here you can now change this thing walk value, and you can pass all, I guess, wall dot filled of I walk value wall dot index of I, and here walk value is wall of map index of key. This is the whole thing, and then you can just run it. It's running correct. We introduce walk with a try to. We have a one final problem. We have one final problem. And remember that map in Go do not guarantee order. Yeah, in map it's not guaranteed. In even in maps, in some of the other like unordered map or uh, we don't have any guarantee. Yeah, so we don't have any guarantee order. So our test will sometimes fails because we assert that a call to a function are done in a particular order. To fix this, we will need more to move our assertion with a map to a new test which we do not care about the order. The test is t dot run with maps function t dot testing which takes on a map of a string. Word God is this walk a map, uh, okay, a map and takes an input which and assert contain which will be a t dot helper contains equals to false range equals to needle contains true. Since we have extended map into new test, we haven't seen the failure message. Intentionally break the with map test here so we can check the error message then fix it again. So all tests are passing. With maps, a map which takes a word god and then got as an array of strings. Walk is a map and the function which takes an input a string got append this and then a sort contains needs to be assert is takes tb and haystack and needle. So t dot helper contains false for x range haystack and then takes that. Okay, that needs to be present so it goes into the contain true, and if it contains is not true then we return an error. It passed. With channels, channels are difficult to be honest. Yeah, so we need to add a test with channels. We already did with a map. Into the channels we firstly create a channel with a profile. The profile is something like this. and then we will be having a go function, and we will be passing into our channel like 33 per lane or other. And then we will close the channel. You can do it deeper. And then we try to got as an array of a string. What? And what we want is a Berlin and get voice. You walk through a channel, takes on an input. Yeah, that looks really cool. Like we will be adding one more cases, right? Yeah, we can do something. We'll do one more test, which is run channel with a function here, and a channel is like make chn, which profile, and then we will do a. It will be in a mapper, like into the map go function, and that go function will be a channel. Will push a profile, and a profile which takes an age which is 33, and then Rahul, and one more a channel which like 544. Um, we can do that video like that, and we can also close the channel. So what will be expectation here? The expectation will be the last value. Uh, Now we got as a array of a string. Font will be array of a string with the value to Rahul, and say, okay, sorry, not like this array. It was a like type, it will be a type. Mhm. And then we walk that walk as a function which takes an interface. So a channel and then our function, like how we are doing till this point. You can see this one, and then we check a deep equal, right? Reflect dot deep equal got and want. We did that here also. Yeah, in the similar way. I mean, there's nothing difference in that. Okay. So if we now run this, it will throw in an error like we got this but want this. Mhm. Now we have to add here one more case which is a channel, and the channel will take a receive the value and then walk. Otherwise, if it does not receive any value, we will break that. Reflect dot channel, and then for we take v and okay. It will be range. No, it will be not range because it comes one value. So if it is a okay, then we will go. Now if it is a okay, we go regularly comma. I did run. Sorry. I mean, uh, yeah, I was also thinking like how it will be going to possible and walk by loop with a we got something, or it is a reflect dot value. is break. Okay, let me understand this. So we will be running till we are getting the value. Uh-huh. And then okay, here what we are doing, here we change that into a function. Now we will check the function. That is super cool. Yeah. So it will be into the simpler way like how we did for a channel. And now if you run the channel, it got passed. So we can comment that CHN. And now we will add leader run with function. Sorry. So with function. So with function, it will be something like function which takes profile and profile. Well, first I am like taking a to profile and returning to profile. Nice. If we returning a profile, right? They will assume it. What's wrong here? Mm, Sorry, I was confused. We will be calling on a function which returns to profile. I thought there would be nothing, and it is taking a to profile and returning. That's why I was thinking like what we are returning here. And we need a got and want in the similar way. So I can change the name as Rahul and this one is a sorry. I don't care like if it is a name or city, I don't care. Is that city? Then we can do no. And then another one is Delhi. Delhi is followed it, bro. I don't care, bro. I said that's why I named it here, even if it is not a city or things like that. Then we will do the same thing. And the work will be a function. We'll take that a function and then an input, and then we'll do our deep equal. Yeah. Now, if you run this, it will fail because as we say, we want this, but we got this, but we want something else. Sorry. Case will be sorry. So into the function, how we will do that? How can you read the value? I think we need to uh, call it or whatever. We need to call it. Yeah, that's the reason I said we need something call way. Call function result. which takes a whole lot call and which takes a nil. And after taking that, we will it will be array reflected. So we take a var or maybe response to the all function result and because it will be reflected value and this will be a range and you can just run that again. Nice. Okay, so we are done with like it takes 2 hours to complete this whole thing. It doesn't like introduce a reflect package. We used a recursive way, did an introspect bad refactor, but did not get too upset about it. And we covered a small expect excellent more detail. Do your best to avoid using it. Yeah, this one is really good. I will read it some. There would be some law, so we will be reading that. I'm keeping this. Here. I think it doesn't have a much use cases. Mm, okay, so we have a sync, and then we also have to cover context. We'll try. Our aim is to complete the till context. We already have been at 2 hours to cover just reflection. We're just taking a 2 minute break and then we'll move to it. Mm. It's really partial. I knew it sucks, saw it coming. This was a ride all along. It's just that the timing for metaverse was way off, and he oversaw the timeline. I believe we might see meta rob and classes gather more spectral intelligence data and use the data because data in the domain is truly scarce. See, I could look for what MSL Meta Super Intelligence Lab is going to do on this. I could really interested if I can create my virtual world by using a prompt. Yeah, so there was something. But, I, when they recently, I'm not. Just let me. I don't remember. Oh, open image in new tab. This one.
Facebook is continuing to dump money into the metaverse. At this point, they've spent about $10 billion dollars in several months of time to build this monstrosity. We're launching Horizon Worlds in France and Spain today. Oh no!
I think, yeah, it looks bit of good, but we'll see it. Like, we will get a lot of improvement also around that. Like, yeah, it looks great to be honest as a starting point, I think. Yeah, but a lot of folks are trolling it. But if you see the video of Google, what Google launches, it is a lot like not it's simpler, but um, Jenny 3 prompted. Okay, let us see if we have an access of Jenny 3. Break Jenny. It is around experiment and sign in. Okay, what we will create it. Oh, we don't we don't know what you are looking for, but we hope you find it. Oh, I don't see anything. Okay, that's cool. That is a metaverse, I think. This one is.
Hey, are you coming?
Yeah, just gotta find something to wear. All right, perfect.
Hey, are you coming?
Yeah.
Really cool. Okay, let us get back to sync. Yeah. So we want to make a counter which is safe to use concurrently. We will start with an unsafe counter and verify its behavior works in a single threaded environment. Then we will exercise its unsafeness with multiple coroutine trying to use the counter via test and fix it. Okay, so it was like we taken a counter, will increase a counter to by one, then like by one every time counter increase, not increase, and again, and then we'll check in the classes that counter is 3 or not. So yeah. uh, I guess we're saying X. The reason for us saying Go because Go have a sync package, so it will, yeah. We don't have a counter, so counter we can just define a counter like that, but it does not gives us anything, and it's returning an a counter, so we can uh, something we can return 0, and here is an integer. Oh, counter is a type. Yeah, counter is type. Oh, I thought counter is a function. Okay, so there needs to be something we need to implement their one of the function that is a ink and a value, because we are checking here and a value and an increment. If we try to run this test, you can see you will get counter.ink undefined. So we need to define ink and we need to define value. Um, so it will be like having it will be on counter. So we do the ink on counter. We'll do a value on in count on in count on counter. I mean, I was getting in counter function. You can say c dot counter, which is inc. Oh, sorry, like that, and then in the sorry, the similar way you can also do for counter, which is value. Let's take a return 0 because it is this way it should be integer then if we're returning any value. And now if we call it, it will throw some other error. So now it says got 0, but we want 3. So we have to take that counter value. We take that counter value and we will plus increment it when we call in inc, and we'll give a value. So we take a value which is an integer, and what we will do c dot input c dot value plus plus, and here we return c dot value. If we now try to run this, you can see it gives you okay. It's not a lot of refactoration, but you can do an yeah, you can do it. It doesn't make any sense there, but the god is like counter. Okay, got that value. Next step, um, it runs safely concurrently. It runs safely concurrently. So we wanted count as a 1000 and then counter, and we add a work group, I mean weight group, and then weight group will add, and we run a go routine, and every go routine we do that will be wait group dot done, and then wait group dot wait we will be waiting till. Okay. Okay, so we can do something like t dot run it safely correctly. We do a function here. We want or we got wanted count. Okay, wanted count is 1000. And we got or a counter we have is this. So what we can do here, we will be running a for loop for to till 1000. Well, let us do it as it is. Wanted count, and then we will do uh, counter plus plus, not counter plus plus, increment, and then after a function we say this the counter and wanted count, and we run if we run this, it takes a time. I mean, I want it to run it again and again, but okay, no problem. How can you make it like how much it takes times to do it? I mean, don't gas it. How should I run it without gas? Um, I mean, there was some way to run it again. Okay, let us run this. Okay, hold it takes 0.369 second. I mean, give a second, bro. Okay, no problem. What we can do, how we can improve that, or we can wait group. That is, I think that comes with a sync dot wait group, right? Uh, and then we need to add all wait group. Add we wanted count, and then we can run it go function, and every time we comes here we do wait group done, we do counter dot increment, and here we will be waiting till everything's not get sorted. Okay, that is how it takes 0.369 seconds last time when we done, and now it taking more time. But it is safely, like you have to attempt it safely, right? Not an issue to get in a memory like on some of other things. This loop through wanted count and fire a go routine to call counter.enc. We are using wait group is a convenient way of synchronizing concurrent processes. A wait group waits for a collections of a go routine to finish. The main go routine calls at to set the number of go routine to wait for. Then each of the go routine runs and calls done when finished at the same time. At the same time, wait group. Wait can be used to block until all go routine have finished. That's what I said. The wz dot wait will be wait till everything get sorted. Everything gets sorted means all go routines have finished. Then by waiting for to finish before making an assertion, we can sure all our go routines have attempted to ink and the counter. Okay. So we get some issues. This test probably failed with a different number, but nonetheless it demonstrates it does not work. When multiple coroutine are trying to mutate the value of counter at same time. Yeah, the problem with it is the same. Like uh, into running this go routine, there might be the chances that we are incrementing at the same value at the same time. So the best thing we have is mutex. So we can lock that thing. I mean, we will lock this thing where we are um, increasing the value, and like every names we call ink, that part will gets locked, and when that gets increased and we are just have to return from that function, that they will unlock it. If it is unlocked, then there will be a panic if you try to read it or try to access it. So it's a bit simple. You can what you can do is just you can come here, you can do mu or m, and you gonna sync dot mutex. There was also there was also a way to do read mutex or write mutex or read write mutex. And what you have to do is just you can call c dot mu dot log. You logged it, and then you can defer c dot mu log. It takes 0.72 seconds. It get cached, that's why. What it means in any coroutine calling inc will acquire the lock on the counter if they are first. All the coroutine will have to wait for it to be unlocked before getting access. Means we are the first which we are going to call inc. So this function get locked. The other will wait to access that same point, or maybe you can say if we are on x slice or x array and we are trying to change a value on that array, it get locked, and the other when other are trying to change the value in the same position, they cannot get access to it as it is locked, and it will wait till it get unlocked. If you are now read run the test, it could now pass because each coroutine has to wait its turn before making a change. Okay. I have seen other examples where sync.mutex is embedded into struct. Hmm. Yeah, I can do that in that way too. It can be argued that it can make the code bit more elegant. This looks nice, but while programming its ugly subjective display, this is a bad and wrong. Yeah. Sometimes people forget that embedded type means the method of that type because part of the public interface, and you often will not want that. Remember that we should be very careful with our public API. The moment we make something public is the moment other code can couple themselves to it. We always want to avoid unnecessary coupling. Exposing lock and unlock is at best confusion, but at the worst potentially very harmful to your software. It if callers of your type start calling these methods. Mhm. Copying mutex. Our code is still dangerous. That statement is right. So it says like copying mutexes. Our test passes, but our code is still a bit dangerous. If you run go wet on your code, you should get an error like following. A call of assert counter copies lock value version 1 dot counter, not context, contains sync. Mhm. Okay. Could we check? We can also check if we want. We can go to sync one. So call up assert functions copy lock value. This okay. And what we run go test with those um, okay. It look like we have a race detected during execution of test. Okay, let us see this one first. Um, Hoping mutex is okay. A look at the documentation tells us why a mutex must not be copied after first use. When we pass our counter by value to assert counter, it will try and create a copy of mutex. To solve this, we could pass in a pointer to our counter instead. So change the signature of assert counter. Okay, our test will no longer compile because we are trying to pass in a counter rather than a counter pointer counter. To solve this, I prefer to create a constructor which show readers of your API. It could be better to not initialize the type yourself. Okay, use this function in your test when initializing counter. Okay. Assert counter passed log by value. It's also giving us so you can do in this way, but it get Mhm. Here you can call to the test the count on behalf of counter. You can call new counter on behalf of counter. You can call a new counter. So new counter will take the counter and return it like that. Now you can run that one. Even if you run now, the race will be, I think, will be there. Mhm. So we covered sync package, when to use log over channel and go routine. We previously covered go routine in the first concurrency chapter, which let us write safe go concurrent code. So why could you use log? A common Go newbie mistake is to overuse channel and Go routine just because it's possible and or because it's fun. Don't be afraid to use sync mutex if that fits your problem best. Go is pragmatic in letting you use the tool uh, you solve uh, that solves your problem best, not forcing you into one style of code. Use channel when passing ownership of data. Use Matex for messaging state. Oh, sorry, managing state. Don't use embedding because it's convenient. Okay, we have this. Okay, I will be reading this. Wow. 9 million. Wow. Okay, that looks good. So my board is like get stuck, right? Okay. Mhm. I don't know why it's looking like that. It is a reason. Well, let me just do it. Because I have this into the model, and this one, and this one. Again, copy this and put in download. Yeah. Now I can use that. Okay. This is really cool to be honest. You can also change background in it. You can also do an auto, so it but I don't use that because their hands are really not that much good. If I do this, you can see artist looks good, but they have some problem with it. And my hairs are also like you can see. Okay. Use a sync.mutex or a channel. So one of the Go motives is share memory by communicating, not uh, uh, share memory by communicating, not communicate by sharing memory, not communicate. That said, Go does provide traditional locking mechanism in sync, mm, but locking issues can be solved using either channel or traditional locks. So which should you use? Use whichever is the most expensive and or most simple. A common go newbie mistake is to overuse channel and go routine just because it's possible and or because it's fun. Don't be afraid to use sing.mutex that fits your problem best. Go is pragmatic in letting you use the tool that solves your problem best and not forcing you into one style of code. As a general guide, uh, passing ownership of data, distributing unit of work, communicating async results, try to use mutex. Okay, if you ever find your sync.mutex locking rule by letting too complex, ask yourself using channel might be simpler. Wait group. Another important synchronization primitive. Oh, sorry. When we try to go for passing ownership, distributing unit of work or communicating async, then use channel. Mutex, where we want to manage the state or caches, then use mutex. We also have a wait group. Another important synchronization primitive is sync.wait group. This allows cooperating go routine to collectively wait for threshold event before proceeding independently again. This is useful typically in two cases. First, when cleaning up a sink, wait group can be used to ensure that all go routine, including the main one, wait before alternating cleanly. Okay. The second more general case is of a cyclic algorithm that involves a set of coroutine that all work independently for a while and all wait on a barrier because proceeding independently again. This pattern might be repeated many times. Data might be exchanged at a barrier event. This strategy is the basic of bulk synchronization synchronized parallelism BSF. Synchronous parallelism, not synchronize. Channel communication, mutex, and wait group are complementary and can be combined. Yeah, that is really cool. We'll read the effective one. Effective one is one of the best talks, to be honest. Okay, we are on the last thing. What was in our aim today? And then we will try to do a reading file one, which is very difficult. So, firstly, we will try to cover context. Someone type, I dare you. Like, let me get the chat. I dare you to quit now and play Resident Evil Village. That's a good. But I'm on a Mac. I have to purchase a PS5. When will I purchase the PS5? Then definitely I will play. I was thinking to uh, end the streaming now. I was getting bit of issues in my throat. Shall we continue till around like the context one? Oh, mutex. Hi. I was like reading the same thing. And someone with same name just joined my stream. Okay, let's go to the context. Oh, was feeling a bit tired now. Mhm. Girl, don't reply. That's cool. Gifted my dad a new phone as was using his current phone for the past 4 years. Now it's time to spoil them with such gifts. That's really cool. And then he will take that same phone. That, okay. So the software often kicks off long running, resource intensive processes, often in a go routines. If the action that caused this gets cancelled for or fails for some reason, you need to stop these processes in mhm, consistent way through your application. If you don't manage this, your Snappy Go application that you are so proud of could start having difficult to debug performance problem. Mm-hmm. Yeah, I can like the long running resource intensive processes mostly are like around the coroutines because like let me say like semaphore running thousands of coroutines like that things. So if you don't manage this, your Snappy Go application that you are proud of could start having difficult to debug performance problems. In this chapter, we will be use the package context to help us manage long running processes We are going to start with a classic example of web server that, when hit, kicks off potentially long-running processes to fetch some data for it to return in the response. Uh, we will exercise a scenario where a user cancels the request before the data can be retrieved, and we will make sure the process is told to give up. Okay. I will set up some codes on Happy Path to get us started. Here's a server code. Okay, so we are just returning the server thing. Okay. The function server takes a store and returns as http.handler function. The store is defined as actually, I'm not using any mic. This is the same through the MacBook, and when I go a bit back to rest my um, heads or maybe that spinal cord. Actually, I'm 6 feet, so I get bit of pain around my spinal cord. So I just get back to it. That's why the it's bit slow. Not slow. I mean, it will be bit low voice. I will try to improve it, but I was just chilling it, and I will do this streaming till 4, not continuous, but yeah, after 4 I'm not free much. Just doing it for first time, just for fun, and revising some of the Golang concepts. That's the reason. Just trying to see like how could I do streaming. I will try to continue such a streaming on Sunday. Maybe some new with AI agents, or build some new things or learning new things on live. Okay. Uh, so we will have a function of a server, and then a store as an interface. We'll have a fetch. We'll add a fetch function. Okay, and then it return the function calls the store fetch methods to get up data and write it to response. We have a corresponding spy for store which we use in a test. Spy store struct response which is in a string, and then a spy store which have a fetch which returns in a string. Okay, we have a test. We have a data as a hello world, and then we have a server which takes an spy store of data that says hello world, and it will return a hello world. Okay, and we already have seen these in HTTP test, so we can mock one around, I mean, HTTP servers. We are not making a real HTTP request, but it is an a mock one. So HTTP test.new request will get a like a method will be get, and then we'll record that HTTP test.new recorder. service dot server HTTP will pass the response and request, and then we'll try to check the response dot body dot string. If it is not equal, then we will say like it's not equal, like that. What we can do, we can do this as something like context underscores. Again, into the X we have a context package, I guess. So the store will have a interface. How's- and into the test we'll have a spy store and fetch. Well, the fetch function, I mean not function, method, and then a test server. That is like a data, and we will pass into the server, and that server will have an function which print w and store fetch. That fetch will be here. The fetch is just returning the response. Okay, it got passed. You can also add a wall. I mean cancel. You can't read it properly, Rahul. Okay, so our handler will need a way of telling the store to cancel the work, so update the interface. We will need to adjust our spy so it takes some time to return data, and a way of knowing it has been told to cancel. It will have to add cancel as a method to implement the store interface. Where we are. Okay, I was not getting any feeling of reading anymore. Okay, so we can close it now, I think. So we have to sleep for 100 millisecond, and then a cancel will be added. Cancel equals to true. We already have a fetch. Mhm. Here you can say cancel as a boolean. Not even boolean, right? Oh, sorry. That will be spy store. Okay, sorry, spy store. And into the spy store, you have to pass in that way. Okay, that is a boolean. Is there any change in store? Uh-huh. We have a way of a store, then we can also cancel it. Mm-hmm. Okay. Okay. Okay, I'm closing it now. We'll do it tomorrow. The context one and some of more thing. I think I'm taking a break, 15 minutes, and then I will read it offline. Okay. I think I can say bye bye now. Yeah. So I can say, oh my God.